Hey, I've got here today another integral on the board. We've got the integral of 1 over cotangent x plus 1 dx. And I think this one's going to go pretty quick. Now, I noticed when I did this problem on paper, because I was able to do it on a sticky note, it tells me I didn't really need much paper, so this is probably going to go quick. Now, I think there's quite a few ways to do this, but what I actually did is I wanted to break this into sines and cosines and then deal with it from there. So what I'm going to do is, let's just rewrite this, and I'm going to write cotangent as cosine x over sine x plus 1. And then what I can do is let's multiply numerator and denominator by sine x. And then we'll just take this and multiply this in and see what we have. So we'll have sine x in the numerator. Then on this term, the sines are going to cancel, and we're just going to have cosine x. I'm just going to write it over here. I like this order better. And then sine x times 1, we'll have a sine x. Now at this point, it's not quite clear exactly how we want to go about this, but what I can do is actually look at what would happen if I made a u substitution for this denominator here. So if I say my u is going to be sine x plus cosine x, and let's take the derivative. So the derivative of this is going to give me cosine x minus sine x dx. Well, I just have sine x here in the numerator, but what I can do is kind of try to force this to happen because we just have sines and cosines here. So the way I'm going to do this is write it, I'm going to create one integral of sine x cosine x over sine x cosine x, just knowing this is 1. So if we use this and this is 1, this is going to be really easy to integrate, right? It's just going to be x. And then I'm going to have another integral here, and I'm going to just force this derivative into the numerator. So we'll have cosine x minus sine x dx. Now here for the second integral, this is going to be really easy as well, because we just have du over u. So we know how to integrate that. We know how to integrate this. So we've kind of forced two easy integrals, but the only thing is, does it add up? Well, when we put these together, if we add these back together, the sines are going to cancel and we end up with 2 cosine x. Well, that doesn't really make sense because we've got sine x here. Well, what I can do if I change, what if I change this to a minus sign here? Now the cosines cancel, we get sine x minus times minus is a plus, we end up with 2 sine x. Well, 2 sine x isn't too bad because then we can just multiply by a half out front. So now you notice the cosines will still cancel, but we'll have a half sine x plus a half sine x with the sines canceling, getting back to sine x. So doing it like this now, we haven't changed the integral. We created 2 easy integrals that we can do. So now at this point, all we need to do is just integrate. So here again, this is going to be just 1 here. So this is going to be half x for our first integral. And then here we have our half out front. Now we've already determined this here is du and this here is u. So for this integral is just going to be natural log absolute value of u. But I'm just going to back substitute in one step because we know what our u is. So we'll just plug that in. It's going to be sine x plus cos x. I'll add a plus c on the end, and that's it. Okay, good integral there. We'll stop it there. Thanks everyone for watching today. Have a great day.